Hello everybody! Welcome to Creating the Basic Adaptable Game Engine Library, Part 26, Bounding Sprites to the Screen. In the previous video, we set out the roadmap of all the different features we'd like to add to Starfish Collector 1.0, upgrading it to Starfish Collector 2.0. The first feature we'll talk about is bounding a sprite to the screen. Now, as the game stands in version 1.0, the turtle can actually move off the screen. So I'll start up the game to demonstrate. So here's our code in IntelliJ for Starfish Collector. Let's go ahead and run this. In every previous playthrough of this game, I very efficiently collected the starfish. But this turtle might take a detour and just fly off the screen. And now we have no idea where the turtle is. The turtle could pop up anywhere. It could be surprising. So what we need to do is somehow stop that from happening. We need to add some kind of a bounding feature to the game to prevent this. So this won't be too hard. What we'll do is we can close the game class for now, and let's go to the sprite class. This seems like the correct place to add something which will keep the sprite bounded to the screen. Now, we should plan this a little bit first. How do you keep the sprite on the screen? Well, we want to check to see if any part of it is moving past the boundaries of the screen. So to check that, here is a handy little diagram. This blue box represents the screen that we want to keep our sprites bound to. And the screen has 4 edges, so there are 4 possible ways the sprite could go off the screen. It could move off the left edge of the screen, the top edge, the right edge, or the bottom edge. So there are 4 conditions we have to check and prevent. Right? Or maybe correct would be a better word. If the sprite moves a little bit off the screen, then we'll just shift it back into the correct position. So right now, the X and Y coordinates refer to the top left corner of the sprite. And remember, when we talk about screen coordinates, the point 0, 0 is in the upper left, the positive x-axis extends to the right, and the positive y-axis extends downwards. So, the sprite goes off the screen to the left if its x-coordinate becomes less than 0, in which case, we'll just set the x-coordinate back to 0. Similarly, a sprite moves off the screen on the top edge if the y-coordinate becomes less than 0, in which case we'll just set the y-coordinate back to 0. Now, going off the right and bottom edges is a little bit trickier. It might be tempting to reason by analogy and say, well, the sprite has gone off the right side if the x-coordinate is greater than the screen width. Not quite. If the x-coordinate is larger than the screen width, that means the entire sprite has made it past the boundary of the screen. But in this case, we don't even want a little part of the sprite to move past the screen, right? Pretending that the edges are solid boundaries that we cannot move past. Right? So in this case, we do not want the right edge of the sprite to move past the right edge of the screen. The x-coordinate of the right edge of a sprite is the sprite's x plus its width. Right, so we want to make sure x plus width is never larger than the width of the screen, which is this x value here along the right edge. If that ever happens, then we'll have to adjust the x. In that case, the x should be positioned over here, which would be the screen width minus the sprite width. And that'll put it in the correct position. Similarly, to check if a sprite goes past the bottom edge of a screen, right, we'd want to check if the y-coordinate plus the height is greater than the height of the screen. If that happens, then we need to readjust the y-coordinate of the sprite. And to get it back up in this position, we would set the y-coordinate equal to the screen height, right, that would be this value down here, minus the sprite height. So there's 4 conditions we need to check. And this function will also need information about the screen itself, specifically the width and the height of the screen. So with that understanding, let's go back to the code. So here we are, back in the Sprite class of the basic adaptable game engine library, and we're going to add a new method. Maybe we'll call it bound to screen. And let's do this maybe before the draw method. So let's create public void bound to screen. And again, we need 2 pieces of information. We'll need an int representing the screen width and another int representing the screen height. Right, and as we mentioned before, there's 4 conditions we need to check. So for example, if this sprite's x position is less than 0, then we want to change the sprite's x position to be equal to 0. Similarly, if the position y coordinate is ever less than 0, that would be going off the top, then we'll set the y coordinate to be 0 once again. So this first if condition checks if it's going off the top. The second condition checks if it's going off, the first is if it goes past the left edge. The second if condition is if it goes past the top edge. Some of you might be tempted to say else if, but it is possible our object could move off the screen at a diagonal, so we really don't want to use else if in this situation. All right, next maybe let's handle the right edge here. So let's say if the position.x plus the width ever becomes larger than the screen width, in that case we need to readjust the x position. Right, position.x, right, to be kind of similar to the others, it'd be great if we could say position.x plus width equals screen width. Right, but we can't set variables like that. Look at that red underlined squiggly. What we can do is move width to the other side of this equation, though. And so screen width minus the sprite width. And then similarly, let's say if position.y plus the height of this sprite is ever bigger than the height of this screen, that means part of it is moving past the bottom edge, in which case we'll say position.y equals screen height minus the height of the sprite. And that's it. That's all we need for a bound to screen method. All right, next, let's just add it into the game. So going back to starfishcollector.java, we'll want to put this in the update function. So update, let's see, so we're checking for overlaps. I'll just put it down here. So let's say turtle.bound to screen. Then we need to give it 2 parameters, the size of the screen. And we had resized this window to 800 by 600, which is also the size of the screen. All right, let's go ahead and give this a run. And let's see if we can get that turtle past the edge of the screen. Hopefully not. All right, so I'm going to hold the up button, and it stopped. Let's try going to the left. Yep, it stops right against the corner of that screen. And I cannot move past that. Now let's go down to the bottom edge. Let's try that. No, it's stuck on the bottom, and go to the right. It also can't go to the right. So we did it. That's the bound to screen method, right? And that'll help your sprites not go off the side of the screen. All right, this is a good first addition to our code. Next, we'll talk about simulating solid objects, but that's a topic for the next video. Thanks for watching.